Friendly Travel Agency provided the following table of information. The table gives the number of customers per day who use a credit card and the probabilities of each. Part A, fill in the missing probability. Well, we know that the total of probabilities in a table has to be 1. So if I just take 1 and subtract all the probabilities that I have so far, that's going to tell me what the remaining probability has to be, so that everything adds up to 1. So 0.36. I'll just put that right there. Perfect. Part B, find the mean and standard deviation. Round each answer to 2 decimal places. Well, I'm going to need to, since I have a table, I'm going to need to put this table into L1 and L2. So the number of customers, I'm going to put here. My probabilities are always what I'm going to be using for L2. It's usually easier to determine what's going to go into L2 than L1. L2s are always frequencies and probabilities, stuff like that. All right, now if I do 1var stats and L1 comma L2, just to kind of make sure I'm getting the using these as frequencies, then I come up with my answers here. So the mean is 9.17 and the standard deviation 0.91. So I round to 2 decimal places as it requested here. Notice I don't get a sample standard deviation, only a population. So clearly that's what you're going to use for your answer no matter what. Parts C, D, and E are all probabilities. Starting with part C, we want the probability that x is less than 10. Well, if x is less than 10, then it needs to either be 8 or 9. So these are the possibilities for x. The answer, though, is a probability. So we need to add these two together here, and that's going to give us the probability that x is less than 10. So 0.28 plus 0.32, that gives me a probability of 0.6. Whoops. Okay. Now, the second one, part D, we want the probability that x is greater than or equal to 9. And the notation I've chosen, just the greater than and the equals right after it, it means the same thing as this symbol right over here. It's just a little bit easier to do this one while typing because this one doesn't have a key on the keyboard. You always have to do some sort of rendering in order to make it work. So this is completely acceptable in terms of representing this concept. So greater than or equal to 9. Well, if it's equal to 9, we can include 9. But it's greater than or equal, so we need to go as far as we can, larger than 9. And so these are the probabilities I want to add together. So I can add them directly, or I could take 1 minus the remaining one. Either way, I'll get the same result because these are complementary. So if I'd added 0.32 and 0.36, 0.03 and 0.01, I still would get 0.72. So either way you go about it, 0.72 is your answer. Okay, now the probability that x is greater than or equal to 8 and less than 11. So it's greater than or equal to 8, so we can include 8, but it's less than 11. So I can't go up to 11, only to 10 because I need that to be less than 11. So these are the only 3 that qualify there. So 0.28 plus 0.32 plus 0.36, and we get 0.96 as the answer there.